Hello class, we're about to start section 3.9, square root functions and their graphs. Working by hand, make a table, sketch the graph of the function f of x equal to the square root of x. Okay, now, when they ask to make a table, since we're asked to make a table here, we make an xy table, and we will put in values in order to find out what f of x equals the square root of x looks like on the graph. So this is what I would suggest. Since we have a square root, we should pick perfect squares. For example, 0, 1, 4, 9, and also 16. When we substitute in 0, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and square root of 16 is 4. Now we will plot these points. We will have 0, 0, we will have 1, 1, we will have 4, 2, we will have 9, 3, and we will have 16, 4. And then now we will graph. Now after we graph here, it says what is the domain of the function. Now we know the domain is the x values of the function. Now if we look here, our lowest x value is 0, but it keeps going on to positive infinity. So if we write this as interval notation, we would do a bracket 0 to infinity. Now it says what is the range of the function. We know that the range is the y values of the function. Now if you look here, your lowest y value is 0, and just like with the domain, the y values go into infinity. So it'd be bracket 0 comma infinity. Now it says here that square root functions have a specific initial point at which the graph starts. In the graph above, the initial point is 0, 0, which we can see here. It starts here and it goes on forever. When graphing transformations of the square root function, it is important to get this initial point in the correct place. Now, one other thing I want to show you is this here. The initial point is 0, 0, but if you notice here with the domain and range, it has the initial point. It has the x value of 0 in the interval, and it also has the y value of 0 in the interval. And that will be important later. Now we flip over to the next page, which is 227. We have graph by hand. First, locate the initial point using transformation of graphs, then plot two additional points. Choose convenient values if possible. Okay, now we have the square root, g of x equals the square root of x minus 3 plus 2. Now we want to do the transformations. Now, we need to look at this. Our initial value was f of x is equal to the square root of x. That is our initial value here for graphing these radicals. Okay, so now if you notice here, what's been added to the square root of x is a minus 3 under the square root and a plus 2 outside of the square root. So this is what happens. With our transformations, with the square root of 3, we know we would go to the right, 3. And then with our plus 2, we would go up 2. Now, we do have a table here. But before we do that, remember what the initial point was when we had the f of x equal to the square root of x. It was 0, 0. So our initial point was here. But our transformation tells us to move 3 places to the right from our initial point, and then go up 2. So this will be our new initial point, which will be 3, 2. That is our new initial point. Now, we have convenient points. We want to plot some more points here. So what I would do is I'm going to add on another column to this table, and I'm going to put the initial point here at the bottom. I know it would make more sense to put it at the top, but I like to put it at the bottom just to show that I've already plotted the point and that we're already using it. but you could put it at the top if you so choose. So now we want to pick points that would make this a perfect square. Now if we make, let's say we make x 4. 4 minus 3 is 1. The square root of 1 is 1 plus 2 is 3. Now our next point, let's do 7. 7 minus 3 is 4. The square root of 4 is 2 plus 2 is 4. And then last but not least, let's try 12. 12 minus 3 is 9. The square root of 9 is 3 plus 2 is 5. Now we will plot all of these points. We will have 4, 3. We will have 7, 4. And then we will have 12, 5. And then now we will connect these points. And now we come down here with the domain. We look at our x value. Our domain starts at 3, and that's included, and it goes on to infinity. Now we go here to the range. Now with the range, we look at the y value. The y value here of our initial point is 2, and as you notice, it continues to go up. So 2 is the lowest value, and it goes on to infinity. Okay, now we move on to page 228. Now with 228, we pick up where we left off at. Again, we have f of x is equal to the square root of x. That is our initial value. And we know our initial point is 0, 0. So when we do our transformations, we're going from the initial point of 0, 0. Our transformation first is that it reflects, the graph reflects. And then also by adding 1, that means it goes to the left 1. Okay, so now these are our transformations. So we would go here. Now the reflection that's telling us basically that the graph is going to flip. But from this point here, it tells us to go to the left 1. So this point here would be our initial point, which would be negative 1, 0. Now again, I would draw another column here, and I would make this negative 1, 0, just to initiate the point that we've already graphed. And now, I'll look for other points here. Now, under this radical, we have x plus 1. So we could start off, let's just do negative 1 for x, and then negative 1 plus 1 is 0. Square root of 0 is 0. Then we could try 3 for x. 3 plus 1 is 4. The square root of 4 is 2. And then that'll give us negative 2. And then we can also try, let's try 0. 0 plus 1 is 1. Square root of 1 is 1. And the opposite of that is negative 1. Now we're going to graph this. We will have, oh, we already did negative 1, 0. That was my mistake. So let me go back and correct this. Since we have negative 1, 0 here, let's correct this and let's put 8 here. So 8 plus 1 is 9. The square root of 9 is 3. So then that would make this negative 3. So you could correct that on your paper as well. All right, so now we can go here and graph. We would go 8 to negative 3, which would be here. Then we would do 3, negative 2. And then 0, negative 1. And we've already plotted negative 1, 0. So we would connect these points. And now, our domain. If you notice here, our domain is the x values. Negative 1 is the lowest value of this domain. So it would be negative 1 to infinity, bracket on negative 1, a parenthesis on infinity. Now the range, we look at the y values. This 0 here for y is actually the highest value here. So that means, if you notice, it's going down. So that means we would go from negative infinity to 0 in a bracket on the 0. And just like I told you in previous problems, we use the initial points in the domain and range. Now we flip over to the last page of this exercise, which is page 229. Now, we have our transformations again. Okay, again, we would have f of x is equal to the square root of x, which is our initial value, and we know our initial point is 0, 0. So when we do our transformations, it's from that point 0, 0. So now, if you look here at this 3, that would mean that the graph would narrow. So what we would do with that is we would put that the graph narrows, which basically means that it's going to stretch. It's going to accelerate much faster. And then the minus 5 on the outside of the radical means that it goes down 5. So now, so we go from 0, 0, and we go down 5. So our initial point here would be 0, negative 5. So we know that's going to be on our table. So we have 0, negative 5. Okay, now we want some other points here. So we go up here, we got 3 times the square root of x. We can use perfect squares. Let's use 1 for x. Square root of 1 is 1. 3 times 1 is 3. Minus 5 is a negative 2. Let's try 4. So it'll be 3 times, matter of fact, let me write that equation here. 3 times the square root of square root of x. 3 times the square root of x, and f of x is equal to this here. So we have f of x is equal to 3 times the square root of x minus 5. Because I'm running out of space here. Okay, so now, if we put 4 in here, the square root of 4 is 2, times 3 is 6, minus 5 is 1. Now we would try 9. The square root of 9 is 3. 3 times 3 is 9, minus 5 is 4. Now, we want to plot all of these points. So now we would have 4, 1. Then we would have 9, 4. And we already, let me see. Oh, we didn't do 1, negative 2, which is here. Now we will graph this here. And as you see, the graph is stretched. Now, we have our domain. We look at our x values. Our lowest x value is 0, and it goes on to infinity. So it'd be bracket 0 to infinity. Now our range. If you look at our range, our lowest range is negative 5, and it goes up to infinity. So it'd be negative 5 to infinity. Negative 5 is included. And as I told you all before, we use the initial point, the x of 0 and a y of negative 5. And that is it for this section.